So just a little intro about me. I've been at Tableau for a little over 6 years, and I have a background in natural language. I lived in the Midwest. I lived in Chicago. That's where I went to grad school. So I fondly remember a lot of road trips I took to St. Louis, so it's good to be back. And the weather is really nice this week. So I just wanted to thank the organizers for having me here. I'm really excited to talk about some of the work. Pretty much the premise of this work is going to craft through a bunch of stories around how natural language was explored at Tableau. Tableau is a data visualization company. I don't know how many people here in the audience knows about Tableau. Raise of hands. Oh, okay, good, okay. Because sometimes I have to explain, yes, Tableau is not a French table making company. So yeah, so when I joined Tableau 6 years ago, there was really nothing about NLP, and over the course of 6 years, that trend has shifted, obviously, and it is a hot area along with the other topics such as machine learning and so forth. So just to kind of get the room a little warmed up, would someone brave enough, promise I won't bite, stand up and quickly volunteer to say the color but not the word itself? Who would like to do it? Great.
Red, blue, green, yellow, green, black. Yellow.
Yeah.
Red, yellow,
Okay.
black, yellow, blue, green, red, black.
Yay. Thank you so much. And what's your name?
Scott.
Scott. Thanks, Scott. Yes. So this was probably a little bit challenging. Sometimes you had to pause and figure out, brain, please don't be confused. And so why is this challenging? It's basically called the Stroop effect in cog-sci literature because our brain is trying to say, read the word. But you're trying to tell the brain, no, I have to actually say the color. So there's a cognitive disconnect that's happening in the way your brain is processing the information between what is being visually represented and what the word is actually means here. So if you've gone to any sort of tech museum or if you have kids like me, you've gone to a science museum, this is a common experiment that people experiment with, and it's amusing, but it also really goes deep into how our visual system works and how we process information. And I'll come back to this as we go through a few examples. So as humans, we're constantly trying to seek information. We look at signage, you look at the agenda in your conference proceedings to see where you want to go, you talk to people, you make gestures, you reason with them, you ask for clarification. So we're trying to make sense of the world. And as humans, we're pretty adept at that because we not only look at the information that's being presented to us, but we also cue off of gestures, your body language, voice intonation, and so forth. But if we were to bring that to statistical graphics, so this is a Sagan brain and body mass chart of various animals, and you're trying to make sense of this chart, your eyes are probably moving towards the blue dots and trying to figure out the text labels next to those dots. And in some cases, because of visual clutter, these labels are often not adjacent to these, so you need to try to decipher the patterns. And if we were to add a little bit of semantics, which is a way to externalize the meaning for this chart by representing these animals with their icons, the patterns become more apparent because you're not trying to visually discriminate between the patterns of the text labels and the dots in this previous chart, but you can actually see what's going on. So this is one of many ways in which semantics, which is a mechanism for adding meaning to information, can provide more effective visual analysis for people. And as humans, we tend to say, I'm not a visual person. I do command line. That's me. Or I just read, books without pictures. But I would argue that our visual system does play a role, whether we are aware of that or not, in many ways. And the visual system is really good at figuring out how to process this information and try to find patterns out of it. So this basically led to a series of work at Tableau. So one thing that I didn't mention is when I joined Tableau, I joined the Tableau Research Group, which consists of about 12 to 14 people. And as part of Tableau Research, I was looking at ways in which we could leverage natural language algorithms to add more meaning to data so that people can stay in the flow of their visual analysis. So one thing that I observed, and a few of my colleagues observed, is I don't know how many of you are sports fans of any sort. And what we have found with a lot of our Tableau users, they spend a lot of time looking at their sports data, their favorite teams or their favorite sport, and they painstakingly go out to the web or try to find icons for these sports teams and use them in their data visualization to add more meaning. So a project that we worked on at Tableau was, how can we minimize the friction when a user is going about their analytical flow by trying to find some reasonable defaults for icons that they could associate with their data? So what we did was we ran an algorithm that took categorical data, say sports teams or names of countries or stock ticker symbols, and just went out to Google Images, fed in a bunch of constraints through its API, and came back with a bunch of images, as you see here. So you have some sports teams on the first row, you have icons of countries in the middle row, and then you have logos of companies at the bottom. Can someone tell me what's wrong with these set of images? Yeah, you were first.
The format of all the images are different. They're not unison.
Exactly. So you see that, for example, the flag for India, the colors are a bit muted compared to Spain. So that could lend itself, if it is used in a data visualization, into some false patterns. Maybe there's something going on in Spain that I need to focus my eyes on, or maybe India is not that important. Another piece of it is the visual distractions of the background. So if you see on the top row, some of the logos have a white background and some of them have a black background. Those changes lead to noise, and then we're trying to process patterns out of nothing. So it's really, really important to provide visuals that are not just meaningful, but also visually coherent. So what we call those as functionally aesthetic imagery. So I'm not going to go into details of the technical details of the work, but at the end of my talk, I do have a link to all our academic papers if people are interested in perusing. But what we essentially did was, take the sports example for a moment, coming back with a set of multiple images per sports team, and then we ran a clustering algorithm to figure out how can we find images that are consistent across aspect ratio, color distribution, and background so that we can come up with these salient images per cluster or per sports team to come up with something that is this, where they're not only meaningful, but they're also functionally aesthetic. So your visual system is not trying to find patterns that are not present in the data, which is really important. So just like icons, if you have used data visualizations or created data visualizations yourself, you often use colors to denote meaning. And we see colors even in our environment, right? I mean, In some cultures, red means it's a warning. In some cultures, red means it's something important. So we use colors and we consume colors in a way that adds some meaning in terms of how we consume that information. So we took that and we worked on a problem at Tableau to try to figure out, given this data, how can we come up with semantically meaningful colors? And for that, we used a data set that came out of XKCD. How many of you have visited the online comic blog XKCD? Okay, a good number. So this is by a cartoonist, Randall Munroe, who has these amazing blogs with a lot of satire and humor and just a lot of insights. And several years ago, he put out a color survey where he showed people a bunch of color swatches and he asked users to name them. And as you can see, if you're a woman or a girl, you tend to be more descriptive in terms of how you would identify these colors. And I would say the guys pretty much stuck to the basics. But what it really gave us was a rich data set of colors and color names that we could use in our research. And in fact, there have been, I would say, 5 to 6 seminal academic papers that came out of this data. So what did we do? Going back to this problem where you have say a list of strings, maybe a list of fruits or vegetables that you want to include in your data visualization, and you want meaningful colors. So going back to the Stroop effect that Scott volunteered in, if I were to assign a color that's not semantically resonant to a data item, it's going to be twice as hard or even more hard to understand what is going on in the picture or in the imagery. So what we did was, if we can take a term and we can find out how colorable that term is and what color typically people tend to identify that term with, what can we do to come up with these more semantically resonant color palettes? So for example, take canary. So we use this feature in Google. It's called the Ngram Viewer that comes up with co-occurrences of how often a word occurs with another term. And it stems from millions and billions of digitized books and literature that is out on the web for people to use. So if you type in canary and I come up with pairs of words with colors, so canary yellow, canary black, canary green, and so forth, canary yellow comes up as most prominent. It's like, okay, canary will probably be associated with yellow. An interesting side effect of exploring the colorability of words was we found events that were defined in history to influence how colorable and what colors were associated with words. So for example, during the Great Depression, sky was associated with gray as opposed to blue. Or when dyes were invented, there was a spike in a particular dye, such as indigo, being associated with blue or bluish purple. So taking this data and figuring out the salient color with the objects, we could take a data set, say, of vegetables, and if you were to just open this in Tableau, Tableau will just blindly associate a default color palette to this list of vegetables. So in this case, broccoli is blue, carrots are brown, and it leads to that Stroop effect that I got to earlier. So using our algorithm, we were able to take these objects, figure out if they are indeed colorable, and if they are colorable, identify them with their salient colors that one can relate to. So now broccoli is a happy green, for instance. And then we had some interesting problems. For example, if I had cherries and apples in the same data set, both of them can be associated with red, but you can't overload the same color to 2 separate data items. But then apple can also be associated with green or yellow, may not be as popular as a red apple, but it's enough for us to create these visually discriminable palettes. So this was sort of kind of scratching the surface, I would say, about 5 years ago in terms of how semantics can affect or influence the analytical workflow by providing some reasonable defaults to a user so that they can stay in their flow of analysis. Moving on from visual encodings, there were other places that we started to look into in terms of applying natural language, because a lot of people think natural language is about talking to a computer or just asking questions. But what we have found out is there are a lot of other aspects, at least in the analytical workflow pipeline, where natural language can add additional semantics to make each of those processes more meaningful or provide reasonable defaults. So a particular problem that we were looking at, I would say, probably 4.5 years ago, was parsing dates. Dates are a very rich, gnarly problem because there's so many ways in which people can express dates. And it's really hard to come up with a standard format to accurately identify that a particular set of strings are not only dates, but they are of a particular format. So we rolled out our first version of parsing dates, and what we noticed on Tableau Public, which is our online offering for Tableau where people can upload their data visualizations and create workbooks, we did an analysis to sort of see how our date parse feature was doing. And to our dismay, we found that it was not doing very well. It was not accurate. Users were getting frustrated. And some of the problems are around some of the things I've highlighted here. So for example, I have these birth dates, and how do I actually interpret this? So if I have 1307, is it January 3rd, 2007, or is it March 1st? Is it a little endian format or a middle endian? Does month come first? Does date come first? And in some places, you can disambiguate based on the locale. So for example, in India, we usually start with the month. But there are other countries where dates supersede the month. So how do we actually do that? And it's not very accurate because locale is not a very good statistic in terms of determining that. So what we did was looking at the context of the column. So if you see what I've highlighted here, you have 4/15/08, and you can't have a month more than 12 unless something really, I don't know, stark happens in the world where we decide to have 3 more months. But by looking at that, we can disambiguate these ambiguous patterns. And it's like, oh, actually, month comes before date because we have 4/15/08. And what was happening was our original feature, the date parse algorithm, was not looking at the full context of the data column, but was looking at just the top few rows. And if you happen to have ambiguous patterns, then bad luck, right? So we revisited that, and we really looked at the context of the column and the data domain to really improve the algorithm and made a lot of customers happy. Another example is in our map search feature at Tableau. So if you open up a map in Tableau, you can actually search for places within your data. And we had the same problem here because you have all these cities. Can someone just tell me which state this is? Texas, right? I actually didn't know that there is a Paris in Texas. It just, based on this problem, I was looking at stuff, and it turns out there is a Paris in Texas, and there is a Montana in Bulgaria. So it was just, and tons of Springfields. So if you're a Simpsons, and interestingly, the Maps team uses Springfield in its test data set to kind of do benchmarking. So, but I don't know, if you guys follow The Simpsons, which Springfield are they alluding to? Who knows? We have a long debate at work. But essentially,
No Springfield. That was the point, I think. Everywhere has a Springfield, so.
yeah, but there was a guy in our office who did a deep dive on all the Springfields in the country, and he actually visited all the Springfields, and he had a separate yes, or a lot of time, or both, yes. But he works on the maps team, so I mean, he took work at a whole new level. So this was our problem. We rolled out our map search tool, and it was using place prominence over data prominence, and Paris was getting highlighted out in Europe, and it was making a lot of people angry about this, especially those who belonged to Paris, Texas, or had business there. And it really drives home this important aspect of natural language, where a lot of people think, natural language is a magic tool. It'll just work. But really, for some of these algorithms to shine, context is really important. And people tend to undermine the value of context when solving these problems. And I think the previous talk in this room alluded to that as well with machine learning. The assumptions is, you have a lot of data, the computer can magically discern patterns, but that's not true. And as humans, we are really good at disambiguating context, both on situation or topic, or to the person you're engaging a conversation with. And it really taught us a lesson to revisit a lot of the assumptions we made when we were implementing features in Tableau, to really look at the context to sort of discern and try to address ambiguity. So that led us to the map search feature at Tableau, where you could search for Paris, and Paris, Texas shows up first, and Paris, France is at the bottom because it's not in the data. So it's more of a data-aware algorithm as opposed to a place prominence-aware algorithm. Okay, so that was sort of kind of the journey in terms of looking and exploring natural language and semantics, and how we can make features a little bit better or a little bit more useful for our users. And then, the obvious thing came about, like, how do we actually support questions in natural language form in Tableau, or in general? I mean, and there was a lot of work that came up from academic literature, I would say around the year 2016, that was looking and exploring ways in which systems can support these analytical questions. And this is where this feature came about. It's called Ask Data. It's a feature that rolled out, if you guys have been following Tableau and its release roadmap in 2019, Q1. And the whole premise of this was supporting questions that are in natural language form. And they're built on Tableau's analytical platform. So it consumes all of the underlying algorithms and show me in terms of coming up with default visualizations. But I think what is really important is multimodal behavior, or this mixed initiative type behavior. So a lot of times when we are crafting interfaces with a particular modality, we tend to get fixated on one modality that will try to address everything, but that's not the case, because different people have different ways in which they use and interact with systems. So how do we actually surface that? So being able to use your mouse to click on a viz, being able to click on a widget, being able to ask a question, and having a combination of that enables a more richer interaction with your interface. And the other aspect of it is just refinement. So one of the things that I'd like to kind of make an important point on is, yes, natural language is going to get better. Accuracy will improve. We'll have data to support that. We can write algorithms for the system to learn a particular user's preferences. But at the end of the day, we also need to provide ways for the system to gracefully fail. And I keep citing this example, but I think it is an important one. With Microsoft Clippy, I think there were a lot of mistakes that were done. But I think one of the main mistakes that I find with such a system was it was trying to get itself right all the time. And the last thing you want to do is tell someone, hey, you're stupid, I know better than you, right? I mean, at a fundamental human level, that is not how we roll. So when you have a system that manifests itself as an intelligent agent, and A says, I think I know what you're doing the moment you open up Word doc, and this is what you're doing, and it's wrong, that's it, right? I mean, as a user, you are not going to use that system or feature again. So I think the natural language community has actually done a 180 from that premise and has really embraced ambiguity being a hard problem and not being able to understand the user's mental model right. And that's where repair and refinement play an important role. So I'm going to talk about that a little bit when I show a demo. But before that, I just wanted to kind of walk you through some of the basic functionality of Ask Data so that when you see the demo, you could identify some of the common functions that we support. So in Ask Data, we support 5 basic analytical expressions. The first one is an aggregation, so being able to say sum of price. What's the sum of price? And being able to group or partition the data into categories. In this case, it's each country. So this user wants a sum of price for each country that manifests into sum of price by country. And shows it as a map, as a default visualization to the user. Filtering is another common task that people tend to do with their data. So asking, where are my wineries? How about in France? And so we support numerical filters, so at greater than, less than, categorical filters, filtering to something, or you have a list of customer names. I want all the customers that contain John, for instance. Limits, which are a type of filter, top 5 wineries or bottom 2 products by sales. And also sorting, being able to sort alphabetically or numerically in ascending or descending order. So I'm going to pause here and show a demo, and hopefully the Wi-Fi is behaving. So let me go in here and kind of show you what Ask Data is about. So Ask Data is available on Tableau server as well as online. And you can actually enter into Ask Data through the data source page on server. And before I do this, I wanted to just show you the entry point. So this is Tableau server, and this is the data source page, and you can actually go into Ask Data through this. And then it'll open up a new window. So the system provides a bunch of suggestions based on your data source, and we have a data pane here, which provides more kind of situational context or grounding to the user in terms of what's in my data, what are some top values for each of my attributes. People who are familiar with Tableau know about dimensions and measures. So dimensions tend to be dates or strings. And measures are more numerical, such as points and price. And most of the team, we have a team in Vancouver, but a bulk of the team is in California, in Palo Alto. So we tend to use either wines or earthquakes as our canonical example. I wanted to have a more happier theme, so it's like, let's just do wines. So let me start off with some questions, and I'll walk you through some of the problems that we had to work on. So average price over time. And if you notice here, as a user, my intent is I probably want to see a time series line chart, but I did not mention the date time field. But the system will infer missing information and find this date time field and say, okay, I'll pick up vintage and group it by year. and show a line chart. Hopefully the Wi-Fi is working. Yes, there you go. So that is one example. And what we found was when we were implementing this feature, underspecification is a common problem, right? When you go to Google, you're not going to spell out full sentences, but you're just going to be very terse and very precise in what you want, and you just expect the system to infer any missing information. And that's just been a consistent feature and challenge that we had to address when we were working on this feature. Some other examples, 2015 wineries. So being able to map wineries to winery, fuzzy match, and also being able to infer the datetime field again for 2015. So I get a sorted list of wineries in the year 2015. I can also ask for top wineries. And if you notice here, the system infers sum of number of records, which is a calculated field that is automatically computed in Tableau. And this is something where we need to infer this in order to generate a visualization. So the types of underspecification we have to deal with are not only user-defined, but also constrained by the underlying analytical system in terms of the parameters that Tableau expects. Some of the other types of intents are around visualization. So I could say list tasters, and the system says, okay, you're asking for a list, so let me infer a text table and give you a text table. And having null here is important. There was always a debate on our team whether we should automatically exclude nulls or not. But as part of data analysis, dirty data is an important aspect. So showing null here is useful to the user so that he or she could figure out what they want to do with that. Another one is country as a pie, where I'm very explicit. I want to view country as a pie chart, but I haven't specified the number or the measure, so it'll infer number of records, and I can change this or repair the system's inference to something else, maybe points or maybe price, and come up with something different. So that is another example where I'm explicitly asking for a data visualization, but I've not specified all the attributes required by the visualization. Something that is more indirect, I could say correlate points with price. And a correlation is best represented as a scatter plot. So even though I didn't explicitly say scatter plot, the system will come up with a scatter plot so that I can look at the correlations between them. And these visualizations are interactive, so this kind of comes back to that multimodal flavor, so that I not only can ask questions, but I can see and peruse and interact with what's there for me, either through these widgets or with the visualization themselves. And because tree maps are very photogenic on the screen, I am just going to put in tasters and points as a tree map, and you get a tree map. There are also some other types of things that we do. So I could say most expensive wineries, and we have a notion of expensive. So it basically maps to price or infers price. So I could say most expensive price by winery, but since I didn't specify that, the system will figure out a numerical attribute that has a currency connotation to it and picks it up and shows me the most expensive wineries sorted in descending order, so that I can look at the relative comparisons of the most expensive one with respect to the others. We also have this notion of what we call vague concepts. So I could say wineries with high points, and I select that. And what does high mean? And the system comes up with a default based on the numerical metadata for points, which is, in this case, 1 standard deviation from the mean. But I can go and change it to something else and save it And the system will learn from that so that it could provide more sensible defaults moving forward. So this is just a flavor of this. So if you, have Tableau or you're interested, feel free to peruse through the feature. And we have some sample workbooks. And we're always open to taking feedback and improving the feature, because I think we've just about scratched the surface, and it's a hard problem. So I'm going to go back to my presentation and kind of walk you through some of the stuff I discussed in the demo, but also some future work. So as I mentioned, inferring underspecified utterances is a hard problem, and this is just another example where I say countries with rank 1, 3, and the system sees that there are two values, 1 and 3, so it infers between. Top 10 countries, the system, in order to generate a bar chart based on Tableau's analytical constraints, has a bunch of measures that it would need to infer in this case in order to generate a bar chart. Same thing with sort product from biggest. Time is an interesting thing. A lot of people will just say sales throughout July 2016. And this is actually a little bit more nuanced, where we not only infer the date time field, but because the value is at the month level, July, we infer one level below month, which is week, in order to generate a line chart. Otherwise, you get a single point because it gets aggregated at the month level. So just a lot of these finer touches to get to what the user's underlying intent is. And this is something I already showed. And sometimes these visualization intents are either explicit or implicit. In this case, it's more subtle, where I just ask life expectancy by location, or just say, show, where are all my life expectancy data, and the user will expect a map. Correlations as well, and inferring vague concepts such as cheap, low, recent, and so forth. And we have these widgets that show the provenance of what the system did under the hood and gives an opportunity for the user to correct and refine the system. So where are we going with this? I walked you through some of the basic stuff we've done with our version 1 of the system, but where we're going is getting into more authentic flows of analytical conversation. You might have seen Google I/O's talk last year, where there was a demo by the CEO, Sundar Pichai, where a human was having a conversation with a computer to book, I think it was a haircut appointment or something. And it was an actual conversation back and forth. So natural language is really getting into conversational flow, figuring out what is the topic of interest at hand, and how do we support this back and forth type of dialogue between a computer and a human. And this feeds really well into repair and refinement, because I might ask a question, and I'm picking on Scott again, and Scott will be like, I don't understand what you meant, and I can clarify that. And that is how one has a conversation with another human. And so that really dovetails well between a computer and a human as well. So now it's my earthquake example. So you can start off with earthquake data, and I can ask, find large earthquakes near California. And I want to be able to ask a follow-up question, how about near Texas, where large earthquakes from the previous utterance is carried on in context to be applied to this? Because it's really frustrating if I have to again type in, show me large earthquakes near Texas. So being able to pivot off of previous context to add, remove, or replace attributes and tokens from the previous utterance is something that we're really getting into from a linguistic standpoint. But at Tableau, linguistics and visualizations go hand in hand. So in order to really support an analytical conversation, we also need to support it visually. So looking at Titanic data, and I ask a question, show me children aboard who survived, and I get a bar chart with kids who survived, yes and no. But being able to ask follow-up questions, like break this down by sex and age. And it's going to be really frustrating if I get a completely different chart and it doesn't preserve the inherent structure from the previous viz. So we're looking at thoughtful ways of not only keeping the structure of language, but also the structure of the visualization. And how do we reconcile between those two? And then when does it make sense for the system to pivot to something else, right? Like I might be having a conversation about lunch, and then I'm like, okay, let's talk shop here, or let's talk about something else. And being able to pivot to something new and getting the system to understand when that happens. So in this case, what is the correlation between age, fare, and survival? Doesn't really make sense to show that correlation in a bar chart. Probably want to show it in a heat map or a scatter plot or a different type of visualization that can support that conversation. Beyond just ask data, there's a lot of exciting research that is also going on. And one of them is just around semantics and meaning. So right now in Ask Data, I can ask price by neighborhood with at least 3 bedrooms. And this is my data. And you can ask that question, and you can also ask follow-up questions such as show me house prices by mapping prices to price. You know, it's a very simple fuzzy match, plurality, or spelling mistakes or typos, sure enough. But then it gets more nuanced because I could say, show me expensive house prices. And right now we have a concept such as expensive that maps to a currency attribute price. But you know, right now our feature has just a few baked in concepts. It's not scalable. It doesn't work for all domains. So how do we actually support these other types of concepts that are not direct translations to the underlying data? Or people have different ways in which they express questions. Show me house cost. You need to know that cost is a synonym of price and being able to map that. You could use a thesaurus. You could use a dictionary. Show me large houses. What is large mapped to? Because there's really no large. Is it square foot area? Is it number of bedrooms? How do you actually infer that? But then, you know, at some point, the system will give up because, you know, show me square footage of houses and you use abbreviations, and, you know, dictionary.com doesn't quite know what that means. So how do, you know, do we go to Google Ngrams where we look at abbreviations, or do we provide self-service to users where they can define these concepts or link to their own domain-specific corpuses? Those are some things that we're investigating. And you know, so just to kind of go a little deeper into what we're looking at is taking the square foot example. I have square foot and I have beds, and being able to go to Google Ngrams and looking at co-occurrence, kind of very similar to the color palette paper that I talked about earlier, finding how often a particular word occurs with another word, for instance. Another part of analytical conversation is on the properties of the viz. What is that spike in that blue line? Being able to map spike to a line chart in the dashboard, where a dashboard is a collection of vizes that are coordinated, and try to find the spike mapped to the color blue is a hard problem. You have to compute the color distance between the term blue, the actual mark property, find the spike, highlight it, and show a tooltip. So there's a lot going on there. Another thing that we've also found is people want more information beyond the context of the data to provide interesting insights. So being able to use external knowledge such as Freebase or Wolfram Alpha or Wikipedia, how do we actually help answer questions like this, where I'm looking at the pound to dollar value and I see a fluctuation, and it's like, what is that drop in July 2016? Being able to go out to the web or to these other data sources, come back with information, and provide a pithy annotation or caption in the viz is a hard problem. I mean, how do we get this right all the time? How do we generalize this to other domains? So with that open-ended thought, I just wanted to pause here and end my talk. If you're interested, there's a bunch of papers that we've published that describe in detail all the underlying work, or if you want to talk to me later, feel free to shoot me an email. I'd be excited to talk to you more. Or simply try out our feature. It's not a plug for getting more eyeballs. It's mostly to get more feedback so we can make our feature better. So with that, I'm happy to take any questions. Yes?
Hello? Okay.
Yeah.
So first of all, great talk. Fascinating problem you guys are trying to solve. That's great. I had a question about, so when you do those fuzzy searches and you're trying to infer what column or whatever data you need to summarize things by.
Yeah.
So a couple questions on that. So first of all, how do you determine without that? And then can the user kind of tell you what it is, or can they change things so the next time you pick the right one and things like that?
Yes,
Thank you.
yes. So when you allude to fuzzy match, are you talking about just underspecified or?
Yes.
Okay, perfect. Yes. So the way we've written the inferencing system is we look at popularity data and the type of data to figure out what would be the most plausible or reasonable attribute that we can infer. And popularity data, and thanks for bringing this up because I did not talk about how we compute popularity data, but popularity data is basically a metric that looks at how often this attribute has been used in other workbooks that use the data source, or how often it has just been used in this feature. So we use that to infer the missing information. And then there's widgets for a user to correct it. So maybe I don't want this particular attribute, I want another one. And the current feature that we're developing, which I didn't demo, the one I demoed was the first version, you can actually also repair stuff through language. So I could say, actually remove X and replace it with Y. So it's a combination of looking at multimodal behavior of a user correcting the system with, with the widget interaction, or using language, and just looking at more passive usage patterns and try to come up with some triangulation of all of those to improve the algorithm. And with a lot of these systems, it's a cold start problem. You don't have the data, so what do you do that is reasonable and does not tick people off? And then hopefully it gets better over time. Yeah, yeah.
So
Yes.
when you call it ask data,
Yeah.
I get an immediate Stroop effect. Have you considered building in voice so you can ask data?
Good question, and I'd actually blame it on marketing for coming up with the phrase "ask data." And yes, it is. I don't know whether it's because the way the feature is named or in general. Yes, voice is something that keeps coming up. Quite honestly, this feature is about a year young. It's very nascent. So we're focused on trying to get the experience right on one platform with one type of modality before spreading ourselves too thin. So that's one response. The other response is, I believe that voice versus typing are not symmetric modalities. There are certain places where voice is very useful. What we've found, with research prototypes we've developed before Ask Data, is voice comes out very handy with multi-touch interactions. So I select a bunch of points and I say, show me the most expensive product here, or the best sales office, which one has the highest sales. So it's a combination of touch and voice that people tend to resonate with, and particularly on these mobile devices. So if we were to just translate the current Ask Data experience and just add voice on a desktop, I guess the question is, how useful would that be? And what would people use it for? So we're still figuring that out. We have a mobile team at Tableau So that's another place we're collaborating and trying to figure that out. Yeah.
Yeah, I'm thinking of when I'm in a meeting with my boss,
Yeah.
I'm showing something. Well, tell me about that spike. Well, that would be obvious. Ask data.
Yes. Go ahead. I wasn't sure. I'm not following who had their hands up.
Over here.
Yes.
So I have a question about ask data. So right now it looks like when you are asking data, it's constrained within the data sets that's loaded in the workbook. What if you want to look at a different workbook and say, oh, that's an interesting pattern. I want to see what it looked like. Say you were looking at the 2016 workbook.
Yeah.
What if you wanted to look at the same thing in the 2015 workbook? Can you do that now? So say,
No.
like, is this pattern in the 2015 data?
Yes. Well, I mean, if the data has the year 2015 and 2016, you can compare the two, even with the current experience.
Yeah.
But we are also looking at new entry points. So right now, you can get into Ask Data from a data source, not from a viz. So, exploring new entry points where I have a viz that I've already authored, and I jump into Ask Data from that point. Or I might have created a dashboard, and you come in, and you're interested in knowing more. Being able to go into Ask Data and ask questions of that viz or the underlying data source is something we're looking into. But I think the long-winded answer to your question is, right now, it's of a data source. And if it happens to have different years, then you can compare them. If not, probably not. Yeah.
Two quick questions. How many people are actually using the Ask Data versus doing it the traditional way of querying? And then what's behind the scenes there? Is it a giant rules engine, or is it one end-to-end neural network deep learning, or is it somewhere in between?
Cool. So to your first question, I don't have the actual numbers, and so it is launched on Tableau server, so it's an on-prem server, as well as online. So we have found that the number of users who are using on-prem, who happen to have 2019.1, are also using Ask Data. There is a bit of a chicken and the egg problem because a lot of people who have on-prem, which are our largest customers, the rate of adoption to upgrading to a new version is about a quarter or two behind because they have to mobilize the entire organization to do an upgrade. So we're actively collecting. So I would say from a percentage standpoint, we have whoever does have on-prem and online with the 2019.1 version, the adoption rate and the stickiness rate is about 69 to 75% of users. But the caveat is we just launched this 3 months ago. So is it a novelty effect? Who knows? So that is just an ongoing set of metrics that we need to monitor. Yeah. The other question, yes. And I do have a paper that we published at the Intelligent User Interface Conference that we presented last month. So that goes into details about the guts of the system. But the short answer is we have a context-free grammar. It's in Chomsky normal form with a bunch of rules. And the rules we have an intermediate language that we call arclang that basically takes natural language input and normalizes it to this intermediate language. A lot of old-time database systems had that premise, but it really helps try to normalize the different variations one might use to express. And then that is tied to the underlying Tableau command language that is called VizQL. So that's the mapping. And the reason why we did not go with either a deep learning approach or a probabilistic grammar was, unlike a lot of the companies that do build these natural language systems, we have customers from all walks of life. Just the domain variety is just too much to come up with a robust parser that will learn for every single domain. So we have it really built in, and now we're adding additional learning algorithms to this predefined CFG with a set of production rules. So yeah. Are you next?
How do you fail? So when you have multiple, like too many keywords, or you cannot detect any a single intent, like what do you do?
Yeah, so it's either as extreme as, sorry, we don't understand what you typed in, but here are some closely matched suggestions to portions of it. And we have suggestions. So that's a hard problem. Like how do you actually know when to fail and how to fail gracefully? And right now, I would say it's a little bit simplistic. It's just through messaging and showing the closest match suggestions, and hopefully a user can take that and refine it, and then we can learn from that.
All right, unfortunately, that's all the time we have.
Yeah.
Another round of applause.